The first thing we need to do is calculate the coupon payment. The formula we would use for that is coupon rate times par value divided by 2. So knowing that, we would do 4% times 1,000 divided by 2, which would give us $28 per payment. The next step of the question is to find the number of periods. So in order to find the number of periods, we know that there are it's 2 years, and then there's a payment every other year, or every 6 months. So there would be 4 periods. Step 3 would be to find the yield per period. So in order to find the yield per period, we would find the annual yield to maturity divided by 2. So in this scenario, we would do 6% divided by 2, which equals 3% per period. Next step would be to calculate the bond price in Excel. So using the Excel equation PV in parentheses rate dash NPR dash payment dash face value, we are able to do equals PV in parentheses 3%, comma 4, comma 5, or comma 20, comma 1,000, with the bond price that would now equal $964.54. All right, so for question number 1.
Okay, so my name is Roy Arnold. I'm a finance and entrepreneurship major. I have a question number 2 out of the 4 for bonds. And it asks us, suppose you purchased the bond on October 31st, 2022. 1 year later, after collecting the coupon payments, you sell the bond, ignoring transaction costs, calculate the prices in the HPR. So what we're given from the bond is the maturity date of 10/31/2032. The coupon rate is 8%, and then the coupon payments are 2, so it's semi-annual. And then redemption value, percent of par, is 100%. And so using this, we are going to have to calculate the price at the purchase, the price at sale, and then the HPR. And so the HPR equation is going to be coupon payments received plus sales price minus purchase price divided by purchase price. So if we're going to do step by step, we're going to do the bond details recap. So the coupon rate is 8% annual, and then 4% per period because there's 2 periods. And then the par value is $100. So for the coupon payment, we're going to do 100 times 8% divided by 2, which equals 4 every 6 months. And then after that, we have to do the price at purchase, or assume the par value. And since it's 100%, it's going to be the purchase price of 100. And then this price at sale is still 9 years to maturity on 2023. So if the yield hasn't changed, the price is going to remain at 100 still. And then coupon payments collected over 1 year. Well, I mean, if it's semi-annual, that's pretty easy. So it's 4 plus 4 equals 8. So 8 coupon payments collected over the 1 year. And then finding the HPR, all you're going to do is 8 plus 100 minus 100 divided by 100, which equals 8 divided by 100. And then you have the HPR of 8%. So our final answer, purchase price 100, sales price 100, coupon income $8, and the HPR is 8%. And that's all.
Hi, I'm Matt Foreman. I'm a finance and supply chain major, and I'm going to be going over number 72 on the bond problems. So for number 72, we're given a table with the price, maturity, and yield to maturity. And we're just filling it out, and then we have par value is given of $1,000. So first off, when we solve those first 3 rows, we're looking to solve the yield to maturity, or the rate. And for that, we're going to use the equation of the par value divided by the price in parentheses, and then that's the power of 1 divided by the maturity, and then that's minus 1. So for that first row, it'll be 1,000 divided by 400 to the power of 1 over 20 minus 1, and we get 4.69. And then for row 2, it'll be 1,000 divided by 500 to the power of 1 over 20 minus 1, and we get 3.53. And then for the third row, it'll be 1,000 divided by 500 to the power of 1 over 10 minus 1, and that equals 7.18%. And then for the next 2 rows, we're solving for the price. So for that, we're going to use the equation where price is equal to the par value divided by 1 plus the rate to the power of 10. So when we do that, for the first one, we'll do 1,000 divided by 1,000 divided by 1 plus 0.10 to the power of 10, and we get 385.54. And then for the next row, we'll do 1,000 divided by 1 plus 0.08 to the power of 10, and we get 463.19. And then for the last one, we're solving for the maturity. And this one, like all the other questions, can be solved in Excel. If you plug in all the different numbers, input your variables, and then use the Excel formulas solving for present value, future value, rate, and all of that. So if we plug everything in, that's the easiest way to do it. And we'll plug in the yield to maturity of 8% and the price of 400, and then we'll get a maturity of 12 years. And then the way this is calculated, kind of like by an equation, would just be the par value divided by the price, and then that is all divided by the 1 plus the rate. So then when you do that, you still get exactly, it'd be 11.91 years, but we're going to round up and do it in a maturity of years, so it's 12 years.
All right, so my name is Connor Rich. I'm a finance and entrepreneurship major, a junior, and I'm going to be covering question 4 of the homework. So basically, the homework, question 4 says, or question 74, a 2-year bond with a par value of $1,000 making annual coupon payments of $100 is currently priced at $1,000. So the first question has to do with what is the yield to maturity of the bond. So let's get our variables down. It's a 2-year bond, face value is $1,000, the price is $1,000, and the coupon payment is $100. So a quick formula to find the YTM is you're just going to do the rate formula. Go on Excel, you type rate, and we have our FV. FV is 1,000 for face value, future value. N is going to be 2. It's a 2-year bond. Price is going to be negative 1,000 just because that's the way you put it in Excel. And then payment is going to be 100. Every 2 payments it gets, or every payment it gets is going to be $100. So the next question, then that's going to equal 10%. The YTM is 10%. You can also kind of just divide the payment by the price there, and you're going to get 10% as well. But the next question is a little bit more complicated, and it says, what will be the realized compound yield to maturity of a 1-year interest rate if the 1-year interest rate next year turns out to be 8%, 10%, or 12%? So basically, they're changing the interest rate from one of the years that the bond pays, or from the first year specifically. So let's say it rises by 8%. What we're going to do is we have to calculate the first coupon payment. The first coupon payment is going to end up being the coupon payment multiplied by 1 plus whatever percentage you're given there. So it's going to be 8%. So it's going to be 100 times 1.08, and you're going to get $108. If you continue, you're going to do it for 10%. 100, which is the current coupon payment, times 1.1, and you're going to get $110. 100 times 1.12, and you're going to get $112. And that's going to be your first coupon payment for each 8%, 10%, and 12%. Now, we already know the second coupon payment. If we know the YTM is 10%, the second year coupon payment is just going to be $100. So we know now the first payment and the second payment. Now we need to calculate up our cash flows for the total of the bond over both years. So we know we use 8% as an example. First payment's 108, second payment is 100, and the face value then gives you 1,000. The cash flows are going to be 1,000 to 108. You go down to 10%, it's going to be 110 plus 100 plus 1,000, 1,210 is the cash flows. Go to 12%, 112 plus 100 plus 1,000 is going to give you 1,212%. Now you need to calculate the realized YTM, because now that we've changed the first coupon payment, the YTM is also going to change. So in this one, what you end up doing is you're going to have to take the cash flows divided by the price. So it's going to be, we'll use 8% as an example, 1,208 divided by the price, which is 1,000, to the exponent of 1 over however many years this bond is, which is 2 years, and then minus 1. So the final equation is going to look like 1,208 divided by 1,000, in parentheses the whole thing, to the exponent of 1 over 2, and subtract by 1. The YTM you're going to end up getting for that is 9.91%. If you do the same thing with the 10%, it's going to be 10%. If you do the same thing with the 12%, it's going to be 10.1%. So it's not a crazy change in YTM because you're only upping it by like $8, $10, or $12, but it is going to change the YTM depending on how the coupon payment changes. So there you go.